Welcome to PureCutCNC, a simple CAD/CAM workflow for designing parts and preparing them for CNC machining. In this video, we'll create a basic model, add machining operations, preview the result, and export the finished toolpath. Let's get started. We'll be building a simple rounded tray with a recessed pocket. It has a solid base, rounded outside corners, and a smaller rounded pocket machined into the top. Click on Draw a Shape to start a new project. For this simple model, we will use rounded rectangle for all shapes. Click on the easel icon in the toolbar and select Rounded Rectangle Shape Creation. We can set corner radius to 1/4 of an inch. Now select the opposing corners of the rectangle. In PureCutCNC, a feature is not just a 2D outline, it defines a volume of material through its shape, top depth, and bottom depth. Add features form the part, while subtract features remove material to create pockets and cutouts. Together, these features build the finished 3D model directly from the sketch. By default, all features inherit their top and bottom Z values from the stock. Here, we want this feature to be recessed slightly into the stock. Now we can add the raised ridge to the model by drawing another rounded rectangle. I am again setting the corner radius to 1/4 of an inch. When a close feature is drawn inside an existing feature, PureCutCNC assumes it is intended to remove material and sets its operation to subtract automatically. In this case, we want the rounded rectangle to add material instead, so we'll change its operation to add and use it to create the raised ridge. Switching to the 3D view confirms the result. The rounded rectangle is now adding material to the model, creating a raised ridge above the base. Next, we'll create the inner pocket of the tray by drawing another rounded rectangle inside the raised ridge. Because this new feature is enclosed by the existing model, PureCutCNC automatically sets it to subtract. By default, its bottom Z value reaches the bottom of the stock, which would cut all the way through. We'll raise the bottom Z value to leave material underneath, creating the floor of the tray. That completes the drawing stage. We now have the finished tray model, ready to create its machining operations. We'll start with the inner pocket. Right-click the pocket or Control-click on a Mac to open its context menu, then select Pocket Operation. The new pocket operation now appears in the Operations panel on the right. Its parameters are shown below, and PureCutCNC has pre-selected a suitable tool for the operation. You can preview the generated toolpath in both the sketch view and the 3D view. The toolpath follows the selected feature. The sketch view shows it in relation to the drawing, while the 3D view shows how it moves through the finished model. The simulation view shows the result of the operation, so you can see the material removed by the toolpath before machining the part. Use the detail slider to adjust the simulation resolution. Higher detail produces a smoother, more accurate result, while lower detail simulates more quickly. Click Play Tool to watch the cutter move through the material and see the operation being machined step by step. You can also adjust the simulation speed to watch the machining process more quickly or inspect it in detail. We could watch this pocket being machined all day. It is strangely hypnotic, but our tray still has more work to do, so let's move on. With the pocket complete, we'll now add a finishing operation to clean up the outer surface of the tray. We'll select the outer feature, then add a surface operation to finish its top surface. The surface clean operation has now been added, and PureCutCNC has generated a toolpath using the pre-selected half-inch end mill. Next, we'll show how to add more tools to the tool library and change this operation to use a 1/4-inch end mill instead. Switch to the Tools tab, then import a 1/4-inch end mill from the built-in tool library. You can also define a new tool manually by entering its dimensions, feeds, speeds, and other settings. We'll then switch back to the operation and change its selected tool to the newly imported 1/4-inch end mill. The simulation view now shows the result of the new surface clean operation using the 1/4-inch end mill. We'll now return to the sketch view and add the final operation, an edge out operation on the outer feature. We'll also change this operation to use the 1/4-inch end mill. Note that PureCutCNC automatically regenerates any affected toolpaths whenever you change an operation parameter or a feature property. Let's return to the simulation view. By default, it shows the result of the selected operation on its own. Switching to Visible includes all enabled operations, showing the final result after they have been applied in sequence. Now we'll give the project a name and save it. PureCutCNC stores your project data locally on your device. Nothing is uploaded or sent to an external hosting service. Before exporting, we can review the completed toolpaths once more. Use the Show toolbar to turn individual move types, such as cuts, rapids, plunges, and retractions, on or off. The direction arrows also show the toolpath's entry and exit points. When you select an operation in the Operations panel, its toolpath is highlighted in the view, making it easy to inspect that operation on its own. Before exporting the toolpath, we need to select the machine type so PureCutCNC can apply the correct post-processor. Open the project properties and choose one of the provided machine definitions. You can also create your own machine definition for a specific CNC controller or setup. Click Export in the Operations panel to export the generated G-code. The export dialog shows the selected machine, project origin, and project units. You can choose which operations to include, enable options such as tool changes or coolant commands, and preview the first lines of the generated G-code before exporting the final file. And that's it. We've created a simple tray, added and reviewed the machining operations, simulated the result, and exported the G-code. Before machining, always verify your tool selections, work origin, machine setup, and generated code. Thanks for watching, and check our YouTube channel for more videos.